Our next speaker is going to take us to the quantum realm. Please welcome a former quantum physicist turned software pharma exec.
Awesome, thank you. Well, now standing here, I'm not so sure about the title anymore because I think I can only underdeliver on the content, but I'll try anyway. So last month, a company called Insilico came out with a new drug in phase 2 trials for pulmonary fibrosis. And the cool thing is they did that in only 18 months, figuring out their first design using mostly AI. And drug discovery is super hard because it's basically a search problem in a space of gazillions of molecules with a very expensive evaluation function. And Insilico tackled this problem by basically generating vast amounts of data themselves and using a series of ML models. And it's cool because developing a drug nowadays is on the order of $1 billion because it takes so much time and because so many trials fail. Now, what does it have to do with quantum computing? Well, initially people thought quantum computing is good for two things: fast database searches and prime number decomposition, which is the thing that you could eventually use to crack all public encryption. Now, 15 years ago, somebody came up with an algorithm that could also speed up machine learning, and that's great. Now, quantum computers don't work like regular computers. Regular computers use electronics, transistors to store and manipulate data. Quantum computers use small physical systems that are very strongly coupled to basically give you an exponential speed up for a small class of algorithms. Now, you can use quantum computers on AWS, on GCP, in your favorite cloud, but now, even today, nobody has come up with an actually useful application, I guess. Except Google, a couple of years ago, they published a paper which they called, or which they coined the term quantum supremacy, where they solved a very academic and kind of a boring system, but they showed that technically quantum computers could be faster than any regular computer out there. Now, for machine learning, it's been shown now that you can speed up exponentially a number of very important algorithms. One of them is principal component analysis. Principal component analysis, if you know, it's one of the algorithms that feeds into, for example, big recommender systems, like the one that is employed by Netflix, where they use vast amounts of data to figure out which movie you should watch next or skip. Now, that's where quantum computers could eventually be useful because Netflix only trains their model a couple times a day, and a quantum computer could do it much, much faster. Now, challenge is, how do you get these vast amounts of data onto a quantum computer? Well, people came up with a thing called quantum RAM, quantum memory, so to speak. And quantum memory is great because there's this thing about it that it could store exponentially more data than regular memory does, or it stores it more efficiently in a way. To show you how efficient it would do that, you can think about 30 qubits, quantum bits. They can store gigabits of classical data. 40 qubits could already store terabits of classical data. Now that sounds great, but the next challenge is, well, how do you get that classical data onto a quantum computer? That's a super hard problem to figure out, and how to get it back is another problem to figure out. But once you figure it out, you basically enter uncharted territory when it comes to the size of machine learning problems that you could eventually solve. And that's great. Now, that being said, in 2019, there was already an academic lab that produced quantum RAM with 100 qubits, so relatively large quantum RAM, but they weren't able to control it really well, so it doesn't do anything useful yet. But, you know, it's a start. Anyway, two more things before I close. Little control is actually a good thing, potentially, because little control we have over these quantum systems because of noise. Noise might be great because you use it in things like stochastic gradient descent, which is, you know, one of the main drivers of neural networks. The other thing that's great about this field is we really understand quantum computing well from a theory perspective. We don't really understand AI well from a theory perspective, why these models are so powerful. So there's a potential synergy to be explored. Now, if you don't want to remember any of what I said so far, my hot take is what I will leave with. I believe that we get quantum machine learning earlier than anybody will be able to crack quantum encryption, which is where most of the money goes now, quantum secure communication and all that stuff. I think you'll see quantum machine learning before that. You find some more info here. If you scan this code, you'll get my LinkedIn, and I took a lot of inspiration from people way smarter than me. Thank you.
Awesome. Thank you very much, Dennis.